Hello, welcome to another video on differentiation. Today we're going to be doing a few problems involving curve sketching. So curve sketching on the AP exam, the AP problems might look a little bit tricky, but it's mostly just process of elimination based on what you know about f prime, and f double prime. So here's a quick review of like the main things about f prime and f double prime, right? So the sign of f prime can tell you whether f is increasing or decreasing, and the sign of f double prime can tell you if f prime is increasing or decreasing, right? Just sort of an extension of this line is over here. But then the other thing with f double prime is it can also show you concavity for a given point. So yeah, concave up kind of looks like a smiley face, and then concave down kind of looks like a sad face. And then you've got an inflection point. So right here, this was concave up, right? There's your smiley face, and then over here, it's concave down. So when you're changing, it's called an inflection point. So main things over here on the upper right hand corner, you're gonna want to check like zeros. Zeros are pretty easy to see usually, and you can eliminate a fair bit of answer choices just with the number of zeros. And then sign changes of anything, of any sort of function, and maybe you might have to look at some minimum or maximum, but yeah, so these things you're gonna want to look at in terms of f and f prime and f double prime and all that. Um, and yeah, the main thing is you're gonna want to make sure that you're checking things that are visible on the other graph. And this will probably make more sense when we get into problems. So yeah, let's start. Here's our first problem. So the graph of the derivative of f, so here's f prime, right there, which is the following could be the graph of f. Okay, so we're going from f prime to f, and these are all choices of f. So important thing to keep in mind there. So okay, now the zeros of f prime will be visible on the graph of f, right? Because a zero on the graph of f prime will just intersect the x-axis, but a zero on the graph of f will be like a horizontal tangent line, right? So yeah, so we have 1, 2 zeros of f prime, and they're both at -2 and 2. So let's just eliminate anything that doesn't have two zeros. So here, f prime is not non-zero, so we can just eliminate that, and same thing for b. And for c, we've got some 2 zeros, so we'll keep that. And d is the same thing. And okay, so we'll just be left with C, D, and E because all of those have zeros. Although C looks a little bit funky because I'm not sure if that zero is close to -2 or exactly at -2. But we'll just leave it. We don't want to eliminate anything that you're unsure of is wrong. So now let's look at the sign of and the sign changes of f prime. So what on the graph of f, if it's positive, if f prime is positive, right, then f is going to increase. So maybe it looks something like this. So using that information, if f prime is positive, then f increases, and the other way around, right? So if f prime is negative, then f decreases. We're gonna like use that with this graph. So here we can see it's negative up to a certain point, -2, and then it's just positive, and then it's negative again. So over here it's decreasing, just abbreviate that, and then over there f will be increasing, and then it'll be decreasing again. So decreasing, increasing, decreasing. That's how our function f should look. So let's see which one of these choices lines up with that. So here it starts out increasing when x is less than -2, so no way that can be true. And the same problem for b actually. So yeah, we've already just arrived at e. We didn't need to do anything else. And you can also verify, right? It decreases, and then it increases, and then it decreases. So yeah, the answer to this question will be E. Okay, this is our final question that we'll be looking at in this video. And it's sort of the other way around. So now we're going from F to F prime. So all of these are choices for F prime. Okay. So first of all, we can't find the zeros of F on the graph of F prime, right? So maybe that's not a great idea, but we can find the zeros of F prime on F. So right, if F prime is 0, then on the graph of F, it's just going to be a horizontal tangent line. I'll just draw it like that. But then on the graph of F prime, it's gonna like cross the x-axis, right? So we have these two representations. So let's use that now. So where is F prime going to be 0 based on this graph here? Well, this is a graph of F, not F prime, and I see only one 0 in between A and B. I'm only considering in between A and B because I'm not quite sure what's happening exactly at A and B. So there's only one 0 of F prime in between A and B. So let's just eliminate anything else. So this is the derivative of F. So these graphs should only cross the x-axis one time in between A and B. So let's see. A looks fine. B crosses the x-axis, or touches the x-axis twice. C's looks okay. D you can also eliminate, and E's looks okay for now. Okay, so now we're left with these A, C, and E. So now we're going to introduce, we're going to look at F double prime, because that will also be visible on both graphs, right? So F double prime, on the graph of F, it'll be like a concave up or concave down. So it'd be like a smiley face or something like that, or depending on what it is. That's how you can see concavity. But on the graph of F prime, right, that is whether it's increasing or decreasing, right? So maybe, I don't know, I'll just do like, in this example scenario, F prime would be negative, so I'm just going to draw that. But yeah, let's use the so we'll find the concavity of this graph F, and then we'll apply that to F prime, and figure out the answer that way. Let's see, it looks like we have an inflection point here. These are sort of the classic inflection points that sort of look like that. So up until this inflection point, looks like the graph was concave up, right? So I'll just write up there to represent concave up, and then until the other inflection point, it's just concave down, and then it's concave up again. Notice how you don't actually need to know like the exact point of the points. Like it's just like where they are relative to A and B in this case. So basically it goes from concave up to concave down to concave up. So what does that mean for F prime? Well, that means F prime goes from increasing, and then it goes to decreasing, and then it goes back to increasing again, right? So let's see which one of these graphs of F prime actually do that. So here it's increasing, and it's decreasing, and it's increasing. Okay, that's fine. That graph C is decreasing first from A, which is not what we want. And then graph E is just always decreasing, so that's definitely not the right answer. So we're just left with A for this question. So yeah, that's it for this video. I hope this was helpful, and I'll see you guys in the next one.